Hi, good evening. Myself Sathyamoorthy, verified plus educator in the Unacademy platform. We are discussing about the differential equations and part by part. Already we had a very good discussion in the previous parts. Already I have completed 4 parts in the differential equations: part 1, part 2, part 3, part 4. Today we are going to have the part 5. In the part 5 we are going to continue with the previous class. Yes. Before moving into this part, I am giving quick revision for the previous classes. Then we are moving into the next one. Higher order differential equation. Okay. Here, higher order differential equation. Higher order linear differential equations with constant coefficient. The general form of the linear differential equation is the general form of the linear differential equation. D power n into y divided by dx power n plus k1 into d power n minus 1 into y divided by dx power n minus 1 plus k2 into d power n minus 2 into y divided by dx power n minus 2 k plus up to the kn into y is equal to x. Here k1, k2, k3 are the constant. These are called as constant coefficients. So higher order linear differential equations with constant coefficient. Yes, the general form of the linear differential equation of the second order is given by d square y divided by dx square plus p into dy divided by dx plus q into y. Here the d divided by dx is replaced by the differential operator d, the single letter d. D divided by dx is replaced by single letter capital D. So dy divided by dx is equal to capital D into y, that is d square y divided by dx square is equal to d square into y. Okay, vice versa, we are increasing the polynomial order here, degree. Okay, we are increasing the degree as well as polynomial order. So coming to the differential equation, the solution for complete solution of the differential equation is y. That is y is equal to complementary function plus particular integral. Here the complementary function is the solution to the LHS of the given differential equation. Particular integral, the particular integral is the solution to the RHS of the given differential equation. In this equation, here capital D stands for the differential operator. When you are getting the D, it indicates that differentiation one time with respect to the x. 1 divided by D stands for the operation of integration. Okay. Then these are the complementary functions used for the equation, complementary function. Here from the differential equation we are identifying the auxiliary equation. These are the roots for the auxiliary equation. These three equations more than sufficient to crack the problems of the differential equation as per the second order linear differential equation. Here roots of auxiliary equations are real, m1 and m2 are the real but not equal. In that category we are using the complementary function for the differential equation is a into e power m1x plus b into e power m2x. Here m1 and m2 are the roots of the auxiliary equation. Then roots are real and equal category. m1 and m2 are same value. Then the complementary function is ax plus b into e power mx or a plus bx into mx. We can use any one of these formula. Then third formula for the complementary function. Roots are imaginary category, alpha plus or minus beta I. Here when we are identifying the root value, okay, it is the category of imaginary. This is the formula for the complementary function. E power alpha x into a into cos beta x plus b into sin beta x. Now coming to the equation as per this content. Yes, particular integral. These are the particular integral formula. The particular integral for the differential equation is 1 divided by f of d into capital X. Here f of d is the differential operator, that is LHS of the given differential equation. Coming to the LHS, It's a LHS. D square into y plus PD into y plus q into y is equal to r. And we are keeping the y commonly outside. So this is the f of d. The function depends upon the variable d. So d square plus PD plus q is the f of d of the given function. So coming to the f of d into x. Here x it may be a e power ax or sin ax or cos ax or x power n or e power ax into pi of x. This pi of x it may be a sin ax or x power n. So these are the two categories. Okay, different methods here. When for all the categories e power ax, sin ax or cos ax or x power n, e power ax category, if we are substituting this value instead of x in the particular integral formula, after making the substitutions, we are getting 1 divided by f of a is equal to 0. Then ordinary rules fails. We have to multiply the x in the numerator. Then the denominator f of d is differentiated one time with respect to the d. Again, after differentiating, again we are substituting these values as per the given format. Again, f dash of a is not equal to 0. This is the condition. Okay, it should be not equal to 0. If f dash of a also 0 in the second step, again we have to multiply x in the numerator. Again second time we have to differentiate the denominator with respect to d with the second time. So this is the procedure for the all the categories. As per this fourth formula, e power ax, sin ax or cos ax, x power n and e power ax into pi of x. As per these four formulas, okay, we are having 8 cases. This is a case 1. Problems based on higher order linear differential equations with constant coefficients. Now here case 1 r which is equal to 0, case 2 r which is equal to e power ax, case 3 in the given differential equation, the left side the function depends upon the variable parameter capital D, RHS it may be a 0, e power ax or sin ax or cos ax. Then case 4 r which is equal to x power n, RHS is equal to x power n. So this is the condition here. Then case 5 here r which is equal to e power ax plus sin ax or e power ax plus cos ax. The case 5. Case 6 e power ax, okay, into sin ax or cos ax. This is the case 6. Case 7 is e power ax into x power n. Case 8 is entirely different case in the differential equation. X power n into sin ax or x power n into cos ax. So this is the format here. Now 1 divided by f of d xv is equal to this formula. We will discuss this in the this class after completing the previous cases. Okay, already we have completed case 0, case 1, case 2, case 3 and case 4, the first 4 classes. Today we are going to complete the case 5, 6 and 7 in the today's class. Possible, if time permits, we are moving into the case 8 also. Now we are going to start the case 5, e power ax plus sin ax. Okay, it's very simple. It's a addition of two cases, case 2 and then case 3 addition. Okay, addition of adding the case 2 and case 3 separately, it gives like case 5. So coming to the case 5 problem. Yes, here RHS is equal to e power ax plus sin ax or e power ax plus cos ax. So this is the format here. Solve d square plus 2d plus 2 into y is equal to e power minus 2x plus cos 2x. Okay, so this is the LHS. Solve. So we have to identify both complementary function as well as particular integral. Complementary function as well as particular integral. Here the particular integral, there are two particular integral. Particular integral 1, particular integral 2. First we are going to identify the complementary function for the given differential equation. before moving to the complementary equation, first we need to replace the letter D by some other letter, because capital D letter stands for the differentiator. Okay, before moving to the class, okay, this is my referral code in the Unacademy. Moorthy, use the code Moorthy MOORTHY 536 to get 10% discount, minimum 10% discount while subscribing into the Unacademy platform. Myself Sathyamoorthy. Okay, please follow my name Sathyamoorthy space V in the Unacademy learning app. Okay, install the Unacademy learning app in your Android mobile. In the search box, search my name Sathyamoorthy space V and follow me in the Unacademy. Then you will get notified each time for the special classes as well as plus courses. Okay, I'm handling the special classes and then plus courses in the Unacademy platform for the theory of machines as well as engineering mathematics. Okay, so coming to this problem, first we need to replace the letter capital D by m. So the auxiliary equation is m square. Instead of D we are replacing m, so m square plus 2m. Instead of here D we are replacing m. 2m plus 2 is equal to 0. So here we need to identify the root. There is no shortcut method available to identify the root value. So we are using the plus or minus, the minus b plus or minus format. We know that to identify the, we are aware of that this form on the school level itself. We know that m is equal to minus b plus or minus root of 4b square minus 4ac divided by 2a. Here we know that a is equal to, from this equation, a is equal to 1, b is equal to 2, here c is equal to 2. Substitute these values here. Then now minus b minus 2 plus or minus b square is equal to, from this equation b square is equal to, here b square is equal to 4 minus 4ac. 4 into a into c is equal to, it is 8. It is 8. So divided by 2. Now minus 2. Now plus or minus root of minus 4 divided by 2. From this equation minus 2 plus or minus root of minus 4 is equal to 2i. Take the 4 outside, so it's 2. Root of minus 1 is equal to I divided by 2. From this equation we are getting minus 1 plus or minus I. If root value is imaginary part, as per the discussion, if the root value is imaginary, it's a complementary function. We had a discussion about the complementary function. When roots are imaginary, that is alpha plus or minus beta I category, then e power alpha x into a into cos beta x plus b into sin beta x. In this previous problem, it is minus 1 plus or minus I. So here alpha is equal to minus 1 as per the previous problem. Alpha plus or minus beta I category. This is the formula for the complementary solution. E power alpha x into a into cos beta x plus b into sin beta x. So coming to the solution for the given equation. Yes. So here we know that complementary function e power alpha x, here alpha is equal to minus 1. Substitute minus 1 here, then into a into cos beta x, here beta value is equal to 1. The coefficient of I is 1, plus b into sin beta x, here beta is equal to 1. Then e power minus x into a cos x plus b sin x is the complementary solution for the given differential equation. Next one, we are moving to the RHS side. We know that the particular integral is the solution to the RHS. Particular integral is the solution to the RHS, that is e power minus 2x plus cos 2x. We are dividing this category into the two divisions, particular integral 1 for the e power minus 2x and then particular integral 2 for the cos 2x. First I am going to identify the e power 2x formula. Okay, coming to the e power 2x, we know that e power 2x is equal to, as per the discussions in the particular integral, we are having the e power 2x f1 divided by f of d into e power ax format. So here we have to keep the e power ax in the front, then 1 divided by f of a. Instead of letter d in the denominator, we have to substitute the a. Okay, so this is the condition. So coming to the substitution, it's a particular integral 1. pi1 is equal to 1 divided by d square plus 2d plus 2 plus 2 into e power minus 2x. What we are doing here, we have to replace the letter d by minus 2. Then replace the minus 2 here, minus 2 the whole square plus 4. So 2 into minus 2, it's minus 4. So plus 2. Then add and subtract 1 divided by 2 into e power minus 2x. So this is the particular integral 1, it's e power 2x. The next one, here cos 2x, this is cos ax or sin ax format. We know that the cos ax or sin ax, okay, we had enough discussions about the cos ax or sin ax in the previous classes itself. Okay, please visit the previous YouTube classes, differential equations discussion on higher order differential equations part 1, part 2, part 3 and part 4. In the first 4 parts, okay, I have discussed about the first 4 cases. Okay, as per the first four cases, here we are moving to the cos ax or sin ax. So coming to the cos ax or sin ax category, here pi is equal to 1 divided by f of d into cos ax. Here we are having the cos ax format. So what we are doing here, in the denominator, the d square, capital D square, is replaced by minus of a square, minus of a square. So this is a procedure here. Now coming to the equation, yes, now 1 divided by d square plus 2d plus 2 into cos 2x. The procedure is, we have to replace the d square by minus of 2 square. So here d square is replaced by minus of 2 square, minus of 2 the whole square plus 2d plus 2. So minus of 2 square is equal to minus 4. Minus 4 plus 2 is equal to minus 2. So 2d minus 2 into cos 2x. Here if you are having only the d in the denominator, the 1 by d stands for the integration, so we can directly integrate. But in the denominator, 2d minus 2, in this category 2d minus 2 category, here again we have to convert the denominator into the d square format. Okay, for that we are multiplying the 2d plus 2 in the denominator as well as numerator. If you are multiplying the 2d plus 2 in the numerator as well as denominator, okay, the value does not change. Okay, so now 2d plus 2, then minus 2 multiplication, it's a square minus b square format. 2d the whole square minus 2 square into cos 2x. Now again 2d the whole square, we know that is 4d square minus 4. Okay, then what we are doing here in this step, we have to replace the d square by minus of 2 square, minus of 2 square. Then again this multiply the cos 2x inside. So 2d into cos 2x plus 2 into cos 2x. Now when you are replacing the d square by minus of 2 square, minus of 2 square is equal to minus 4. So minus 4 into 4 minus 16. Minus 16 minus 4 is equal to minus 20. Minus 20. So this is the procedure here. Here the multiplication of d stands for, in the numerator d stands for the differentiation. So we have to differentiate the cos 2x one time with respect to the x. The differentiation of cos 2x is equal to minus 2 into sin 2x. So minus 2 into 2 minus 4 into sin 2x plus the 2 into cos 2x. Now divide this term, 4 divided by 20, it's 5. So minus minus cancel. Sin 2x divided by 5, 2 divided by 20 is equal to 1 divided by 10. So minus cos 2x divided by 10. So this is a particular integral 2, pi2. Coming to the equation, it is pi1 particular integral 1. This pi2 particular integral 2. Yes, pi2 is equal to sine 2x divided by 5. As per the discussions here, pi is equal to pi1 plus pi2. Now, the complete solution is a particular integral pi1 plus pi2. Now, add the 1 divided by 2 into e power minus 2x plus sine 2x divided by 5 minus cos 2x divided by 10. So, this is the procedure. Y is equal to e power minus 2 into a into cos x plus b into sin x plus e power minus 2x divided by 2 plus sin 2x divided by 5 minus of cos 2x divided by 10. So this is a complete solution for the given differential equation. This is the case 5. It's the same as our case 2 plus case 3 format. Okay. Next we are moving to the next case. There are variety of cases available, 8 cases with case 0, case 2, 3, 4. Now we have completed e power ax plus sin ax or cos ax format. Now we are moving into the case 6, RHS is equal to e power ax into sin ax or e power ax into cos ax. Then the same category we are moving here, case 7 also. Combinedly we are going to discuss the case 6 and 7 now. Okay, RHS is equal to e power x into sin x. In this category, for this category, what we are doing in the particular integral, when e power x into pi of x, the pi of x, it may be a sin x or here pi of x, it may be a is equal to sin ax or cos ax or x power n or x power n. It may be x power n or sin ax or cos ax. Now, yes, here in this category, as per the procedure coming to the table, 1 divided by f of d, 1 divided by f of d into e power ax into pi of x is equal to e power ax divided by, here we have to take this e power x, okay, here front side, then we have to replace the denominator instead of d plus a, here e power ax, so we are substituting d plus a. If you are having e power minus ax, here d minus a. So it's a procedure. What we are doing as per the case 6 and 7, 6 and 7, if you are having e power ax into sin ax or e power ax into cos ax category or e power ax into pi of x, thing is we have to take this e power ax front side into in the denominator in the f of d function, we are replacing letter d by d plus a. If you are having e minus ax, d minus a again into that pi of x into this pi of x. Again, it's okay. Keep this e power ax as constant. Again, continue with this function as per the pi of x function. If it is sin ax, we have to continue with sin ax formula. If it is x power n, we have to continue with x power n formula. So coming to the next case. This is the next case. RHS equal to e power ax into pi of x. RHS equal to e power ax into pi of x into pi of x is equal to sin ax or cos ax. Pi of x is equal to sin ax or cos ax. Okay, or x power n. The first problem. Okay, now I am explaining one problem. Next we are moving into the practice questions based on the case 5 and 6. Particular integral of d square minus 2d plus 5 into y is equal to e power x into cos ax. This format is e power x into cos ax format. Now the thing is particular integral is equal to 1 divided by f of d into e power x ax into cos ax. Here in the denominator we have to take this e power x here. Here a is equal to 1. So coefficient of x is called as parameter constant a. Here a is equal to 1. Then we have to take this e power x front side. In the denominator, instead of capital D, we are replacing capital D plus 1 the whole square. Capital D plus 1 the whole square minus 2 into D plus 1 plus 5. 2 into D plus 1 plus 5 into cos 2x Then we have to simplify this denominator. Then we have to operate the equation with cos ax format. Then keep this e power x constant into d plus 1 the whole square is equal to it's a plus b the whole square format. So here a square is equal to d square plus b square is equal to 1. 2ab 2 into d into 1 is equal to 2d. Now multiply this minus 2 inside. When you are multiplying the minus 2 inside, minus 2 into d is equal to minus 2d. Minus 2 into 1 is equal to minus 2. Then plus 5. Then as per the simplification format here, minus 2d plus 2d cancel. Now 5 plus 1 6. 6 minus 2 it is 4. 6 minus 2 it is 4. So remaining thing is d square plus 4 into cos 2x Okay, take it as e power x constant. Now we have to operate with cos ax format. For the cos ax, coming to the explanation cos ax, the formula it is cos ax or sin ax. In the denominator we have to replace the d square by minus of a square. So coming to the problem, here in the denominator d square is replaced by minus of 2 square. Minus of 2 square is equal to minus 4 plus 4. Now denominator is equal to 0. When after substituting this value, here f dash of a is equal to 0. Minus 4 plus 4 0. If denominator is equal to 0, if ordinary rule fails, from this equation it is equal to e power x into 1 divided by 0 into cos 2x. Ordinary rules fails. Ordinary rule fails because of denominator is equal to 0. If ordinary rules fails, that is f dash of a is equal to 0. Okay, if f dash of a is equal to 0, okay, we know the procedure to apply here. When f dash of a is equal to 0, this is the procedure. When f of a in the denominator is equal to 0, we have to multiply the x in the numerator. Then we have to differentiate the denominator one time with respect to the d. Again we have to operate as per the cos 2x format. So coming to this case, here, so multiply the x in the numerator. This d square is differentiated one time with respect to the d square plus 4. The d square differentiated 2d. The 4 differentiation equal to 0 constant. So 1 divided by 2d. Here 1 divided by d. Okay, without any addition or subtraction from the 2d, it's separately 1 divided by 2d. 1 divided by d, the multiplication of 1 divided by d stands for the differential operator. So coming to the explanation differential operator. Okay, I think already we have discussed this thing. 1 divided by d stands for integration. So we have to integrate the function one time. If you are having 1 divided by d square, we have to integrate the given function 2 times with respect to the x. Now multiplication x here differentiated. Now 1 divided by d. D stands for one time integration. We are integrating the cos 2x. We are getting sin 2x divided by 2. Already we are having 2. sin 2x divided by 2. One more thing in the 2. So x into e power x into sin 2x divided by 4. So this is the particular integral for the given equation. This is the particular integral for the given equation. Okay, is it clear? Okay, learners. Okay, the live learners. Okay, those who are watching the live chat. Okay, live video. Okay, you can ask your doubts in the live chat. Okay, comment your doubts in the live chat. So here I am to help you guys. Yes. The next one, again, find the particular integral of. There are two cases. For each cases, we are discussing about the two cases here. As for the e power x into pi of x, it may be a sin x cos x or x power n. As per this formula, we are having two cases. The case 6, e power ax into sin x or e power x into cos ax. Already we had a discussion about this case. Next case is e power ax into x power n. Now we are going to discuss about this thing, e power ax into x power n. So coming to the e power ax into x power n, this e power ax into x power n category. Find the particular integral of d square minus 4d into y is equal to e power x into x. Now, the procedure, particular integral is equal to 1 divided by f of d. This f of d is equal to d square minus 4d into e power x into x is equal to e power x into 1 divided by the thing. When you are taking this e power x front side, we have to replace the d by d plus a. Here a is equal to 1. So coefficient 1. So d plus 1 the whole square minus, instead of d we are replacing d plus 1. Now into x. Now expand this denominator, then operate with respect to the x into x format, x power n format. So 1 divided by d plus 1 the whole square is equal to d square, that is a square, plus 1 square plus 2d minus 4d minus 4. Now the simplification, d square minus 4d plus 2d, that is minus 2d, minus 4 plus 1, it is minus 3. So e power x into 1 divided by d square minus 2d minus 3 into x is equal to e power x into minus 3, e power x into minus 3 into 1 divided by 1 minus d square minus 2d divided by 3 into x. This is the procedure here. What we are doing, the denominator is converted into 1 plus x format. So binomial expansion format. This format, the denominator is converted into 1 divided by x format. 1 divided by x format. Again, this 1 divided by x is taken into the numerator. So 1 divided by x whole to the power minus 1. As per the binomial expansion, we have to change it. Yes. So here, why we are converting it to the 1 plus x? Now convert this 1 plus x format. So take this minus 3 outside. Now taking the minus 3. So 1 minus the whole term d square minus 2d divided by 3 is correspond to the x. It is corresponds to the x. It is 1. It's 1 plus x or 1 minus x category. It may be a 1 plus x or 1 divided by 1 minus x. The is equal to 1 minus x whole power minus 1. We have to convert any one format. Now we are converting 1 minus x format. We are taking 1 minus x. Here it is correspond to 1. It is x. So 1 minus x whole to the power minus 1. The binomial expansion. First we need to expand this formula as per the binomial expansion. Coming to the binomial expansion, This is the binomial expansion. Okay, I think we had a discussion about this formula in the previous classes itself. 1 plus x whole to the power minus 1 is equal to 1 minus x plus x square minus x square plus x power 4, okay, vice versa. We are increasing. Now 1 minus x the whole power minus 1 is equal to 1 plus x square plus x cube plus x power 4. Okay, we are expanding. The shortcut to remember this formula here, plus minus. So alternative symbols used here. So plus minus plus minus plus minus. We are using alternative symbol. Then as well as we are increasing the polynomial order of the x. Here the second formula 1 minus x minus the whole power minus 1. Both are same symbol. So same sign. We are using continuously plus symbol. 1 plus x square plus x cube plus x power 4. Okay, we are expanding as per this. Okay, Naga Mohit, hello Mohit. Okay, we are in a live chat now. Then as per this formula, we have to expand it. So coming to the explanation. Now 1 plus x, the formula is here as per the discussion, the formula is equal to 1 plus x plus x square plus x cube, vice versa. We are increasing. Now coming to the formula slide, as per the formula 1 plus x square plus x cube. But okay, we have to decide. Okay, then okay, how to we have to how we are expanding this binomial expansion. Based on the x power n, we are expanding the binomial equation. Here x power n is equal to 1. So we have to start up to the d itself. More than the power d, it gives 0 because so differentiation as per the differentiation. 1 time differentiation of x equal to 1. 2 times differentiation d square of x is equal to, it is equal to 0. So the order here power differential order more than 1 eliminated in this equation as per the 2. If you are having x square, so we have to expand up to the d square. The d cube of x on which we are getting 0. Here x power 1, so we have to start the power up to the 1 d. The more than the d eliminated. Here we are having d. When we are squaring it whole square, we are getting more than d. So we are eliminating this term. So we are eliminating this term. So coming to the equation now, 1 plus d square, 1 plus d square. So here d square also higher order, 1 plus d square divided by 3 minus 2d divided by 3. Here this d square divided by 3 also higher order we are eliminating. Then 1 minus 2d divided by 3. Multiply the x inside. We are multiplying x inside. We are multiplying the x inside. 1 into x, it is x. So minus 2 divided by 3 into d of x. So d of x is equal to 1. So 2 divided by 3. So answer is minus e power x divided by 3 into x minus 2 by 3. So this is the answer for the given particular integral equation. The next we are moving into the next equation. Okay, we had a discussion. The next slide onwards, we are going to have the multiple choice question as per the case 6 and 7. Okay, the first question. Okay, now the question was activated in the slide. Okay, learners, bring your paper and pen as per our discussion, work it out and comment your answers in the live chat. Okay, after that I will explain this problem here. I will work out this problem in the slide itself. Okay, now I am solving this problem. Okay, anyway, try your problem in your end. Coming to the explanation, particular integral of d square plus 2d plus 1 into y is equal to e power minus x into x square is minus e power minus x into x square is. Okay, what is the solution for the given equation? We know that particular integral is equal to particular integral pi is equal to 1 divided by f of d. and f of d is equal to d square plus 2d plus 2d plus 1 into e power minus x into x square. The thing is, we have to expand this formula. We have to expand this formula here. When you are expanding this, we have to take this e power minus x front side. In the denominator, instead of d, we have to substitute 1 d minus 1. So d minus 1 yes, here d minus 1 the whole square plus 2 into d minus 1, 2 into d minus 1 plus 1 into x square. Now keep this e power minus x is constant, then simplify the denominator. Coming to the simplification for the denominator, it is equal to e power minus x into 1 divided by, expand this formula, d square a minus b the whole square formula, it is d square plus 1 minus 2d. Now multiply the 2 inside, plus 2d plus 2d minus 2 plus 1 into x square. So this is the formula here. As per this discussion, minus 2d plus 2d cancel, plus 1 minus 2 plus 1. It's again it is 0. Now is equal to e power minus x into 1 divided by capital D square into x square. The 1 divided by d stands for the integration. 1 divided by d square stands for the 2 times integration of the given function. So now one time integration e power minus x into 1 divided by d. One time integration equal to x cube divided by 3. Again second time integration e power minus x into x power 4 divided by 3 into 4. That is equal to 1 divided by 12 into 1 divided by 12 into x power 4 into e power minus x. E power minus x. So this is the answer. So coming to the answer, 1 by 12 into x power 4 into e power x. So option C is the correct answer as per the discussion here. Option C. Option C is the correct answer for the given question. Next we are moving to the next question. Ladies, if you are having any doubt, okay, please comment your doubts in the live chat. So I am here to help you guys. If you are having any doubts regarding this case 6 and 7 in the differential equation, okay, comment your doubts in the live chat. The next problem to you. Yes, this is the next problem. Particular integral of d plus 2 the whole square into y is equal to e power minus 2x into, coming to this explanation, e power minus 2x into sin x is, okay, what about the answer for the given question? Okay, yes, be ready with your answer. We will work it out and then I am solving this problem here in the slide itself. Okay, from your end, work it out this problem in your paper and then comment your answers in the live chat. So coming to the explanation, particular integral, we know that Pi is equal to Pi is equal to 1 divided by d plus d plus 2 the whole square, d plus 2 the whole square into e power minus x into 2x minus 2x into sin x. So this is the procedure. Now we have to take this e power minus 2x front side. As per this discussion, e power minus 2x into 1 divided by, instead of d, substitute d minus 2. We are substituting d minus 2, then plus 2 the whole square. the whole square into here sin x. Now substitute here e power minus 2x, e power minus 2x divided by the plus 2 minus 2 cancel, so 1 divided by d square, 1 divided by d square into sin x. Here e power minus 2x into sin x. Then one time integration is given it as e power minus 2x divided by d. One time integration is integrating, it is minus cos x. It is minus cos x. Again integrating, it is minus of minus. What we are getting? E power minus of minus e power 2x into integrating the cos x, we are getting sin x. So the answer is equal to minus e power 2x into sin x. So as per the discussion here, the solution is option B. So option B is the correct answer for the given question. Yes, option B is the correct answer for the given question. That is minus e power minus 2x into sin x. As per this discussion, the next one, we are moving into the next problem. So next problem, particular integral of d minus 1 the whole square into y is equal to e power x into sin x. So let us work your problem. Okay, work out this problem in your paper and ping your answers in the comment box, live chat box. Now I am solving this problem here. We know that the particular integral pi, as per the discussion, same procedure. pi, we have to identify the correct answer among the four options. So pi is equal to 1 divided by f of d. The f of d is given it as d minus 1 the whole square. D minus 1 the whole square into e power x sin x. E power x into sin x. Now the thing is, we have to take this e power x front side, instead of d in the denominator, d plus 1, so is equal to e power x in the denominator, d plus 1 minus 1 the whole square into sin x into sin. So again we have to operate with the sin x format. We are operating with the sin x format. In the previous problem, we can take any one. Okay, I will explain it. E power x divided by, so minus 1 plus 1 cancel, that is d square. That is d square into sin x. Okay, here thing is, instead of d square, we can replace the minus of a square, Otherwise, we can use it as 2 times integration. Both are correct. So now I am giving here, instead of d square, I am substituting minus of a square. So e power x, here instead of d square, I am substituting minus of 1 square, into sin x, The answer is minus e power x into sin x. So this is the answer. Minus e power x into sin x. So here the correct answer is option A is the correct answer as per our discussion. Option A is the correct answer for the given question. Okay, now the previous problem, same procedure. in this problem we have different integrated 2 times. Now one more thing, from this step itself we can conclude that instead of 2 times differentiation, 1 divided by d stands for the integration, 2 times integration, we can substitute the procedure. So d square is replaced by minus of a square. So from this equation, e power minus 2x divided by minus of 1 square into sin x the same answer, we are getting the same answer, that is e power minus 2x minus of minus e power 2x into sin x. So this is the procedure. Okay, as per our discussion, we are moving into the next problem, the same procedure, case 6 and 7. Yes, the particular integral of d power 4 y divided by dx power 4 minus y is equal to e power x into cos x. Okay, we have to solve this problem here. The particular integral, we know that the particular integral is equal to pi is equal to 1 divided by f of d. Here f of d, first we have to convert the equation in this form. First equation, d square y divided by dx power 4 minus y is equal to e power x cos x is converted cos x is converted. Okay, the instead of d divided by dx we are substituting capital D square into y minus y is equal to e power x into cos x. Now take this y outside, so d minus 1 into y d minus 1 into d square minus 1 into y is equal to e power x into cos x So we have converted the given differential equation in terms of letter d. As per discussion, particular integral, we know that a particular integral pi is equal to particular integral given by pi is equal to 1 divided by f of d, that is d square minus d power 4, here d power 4, it's d power 4. So coming as per the d power 4, d power 4 divided by dx power 4, here d power 4 again d power 4 minus 1 the into here e power x into cos x. Here we are converting this term into the different form. How we are converting? This equal to 1 divided by d square, okay, a minus b the whole square, a square plus b square. We know that as per the discussion we can take it to the new term, so d power 4, here take this e power x front side, so instead of d we are substituting the d square the whole square, here 1 divided by d square the whole square, d power 4 is replaced by d square the whole square. So d square, this formula, d for 4 minus 1. Coming to this formula, d square the whole square minus 1 into e power x into cos 2x into cos 2x. We can use this formula, otherwise we can use d power 4 minus 1 instead of d square minus 1 square the whole square. D square minus 1 square the whole square. There are two things are available. So coming to the equation. Now replace this equation is equal to e power x is taken into the numerator, sorry, front side. So d square, instead of d square we are substituting d plus 1 the whole square, d plus 1 the whole square into the whole square, minus 1 into cos x into cos x. So this is the procedure here. Now from the previous step, what we are doing here, the d square the whole square, now cos x, expand this formula as per the procedure, e power x divided by d square plus 1 plus 2d plus 2d the whole power square minus 1 into cos x, Now the replace the d square in the denominator by minus of a square, So e power x divided by the d square is replaced by minus of 1 square plus 1 plus 2d the whole square, minus 1 into cos x, Now minus 1 plus 1 cancel, 2d the whole square, that is equal to e power x divided by, cancel this term, okay, then remaining 1 divided by 2 square is equal to 4 into capital D square minus 1 into cos x, Again the same thing, instead of capital D square, we are replacing minus of a square as per the discussion. So coming to the as per the discussions in the table, this is a procedure. As per the procedure, we are replacing here sin ax or cos ax in this format for the particular integral. Instead of d square in the denominator, we are replacing by minus of a square, So as per the minus of a square format, coming to the equation here, yes. So replace the d square by minus of 1 square is equal to e power x into 1 divided by 4 into minus of 1 square, minus 1 into cos x, is equal to, now minus 4 minus 1, it is minus 5, as per the discussion it is minus 5. Equation is given it as e power x into 1 divided by, it is minus 4 minus 1 into cos x. Now from this equation, the solution for the equation is given it as e power x into 1 divided by minus 5 into cos x, Wait a minute. e power x divided by minus 5 into cos x. As per discussion, the solution for the given equation is minus 1 divided by 5 into e power x into cos x. That is the solution. So here the option C is the correct answer. So I am marking C is the correct answer for the given question. Yes. So these are the cases. We had a very good discussion about the case 6 and 7. These are the different cases available in the differential equation. These 8 cases are more than sufficient to crack the problems in the higher order differential equation. We had a discussion about 6 and 7 in this class. Case 1, 2, 3, 4, 5, already up to the 4 we have completed previous classes itself. Today we had a discussion about case 5, that is e power ax plus sin ax or cos ax format. Then case 6, RHS is equal to e power ax into sin ax or e power ax into cos ax category. Then case 7, RHS is equal to e power ax into x power n. So these are the cases we have discussed. In the forthcoming classes, we are going to discuss about the case 6. Then we are moving to the next class onwards, Euler-Cauchy equation. This higher order differential equations for the constant coefficients. Today we have discussed about the problems based on higher order linear differential equations with constant coefficients, and the coefficient is variable. For the variable coefficient, so we have to use the different procedure. That procedure is Euler-Cauchy equation. As per the Euler-Cauchy equation, we are going to derive the differential equation. Okay, stay tuned in the Unacademy platform as well as in the YouTube live class to discuss about the higher order differential coefficients with variable constants or variable coefficient the next class onwards. Okay, thank you. Until bye from Sathyamoorthy. Thank you so much.